So today we're going to cover section 2 of chapter 2. And today what we're going to learn how to use is inductive reasoning. We're also going to take a look at deductive reasoning and learn a couple laws of logic. So the first thing we're going to do is define what a conjecture is and what inductive reasoning is. And a conjecture is just an unproven statement that's based on an observation. So for example, let's say you observe me going to the roof of the school, and I get on the roof and I've got a ball and I throw it off the roof. And you're observing that every time I throw that ball off the roof, it falls to the ground. And I do this repeatedly. So you can make a conjecture based on what you're seeing when I throw that ball off the roof, that every time I throw the ball off the roof, it's going to fall to the ground. That would be a conjecture that you could make. It's just a statement based off of your observation. And when you make your conjecture based on an observation or a pattern, you're using inductive reasoning. So we would watch something occur over and over again, or you might even be given a pattern of numbers. And if they ask you to figure out what number would come next in the pattern, then you're making a conjecture. And you're looking for a pattern or something that's happened in the past. So for example, let's say I gave you the pattern of numbers 2, 4, 6, 8, and I ask you what number would come next. And if you look at this pattern, you can look and see that in this sequence, the pattern would be they added 2 each time. So the next number in this sequence, by following the pattern, would be to add 2, and the next number would be 10. So when you look at a pattern of numbers to see what they're doing to complete it, this is using inductive reasoning. Now when you are given a sequence of numbers, if the pattern gets larger, you're either adding to complete the sequence or you would be multiplying. If it gets smaller, you're using either subtraction or division. Now let's look at another pattern question, but this time doesn't have numbers. It's got pictures. So for this one, it says, describe how to sketch the fourth figure in the pattern, and then sketch the fourth figure. So let me go ahead and let me draw a circle here. So this is going to be figure number 4. I'm going to draw a circle. So what do you think is going to happen with figure 4? How many sections do you think I need to make?
8.
Okay, 8. Good. So notice the first one had 2, the second one had 4, and then the next one had 6. So what kind of conjecture could you make? So you can see that this one's going to have 8. So what do you think they did to each one, from going from 1 to 2 to 3 to 4? What did they do to figure out the sections?
Add 2 more little spaces.
Okay, so they went from 2 to 4 to 6 to 8. They added 2. That would be a conjecture that he could make. He could say that for each figure that increased in the pattern, he added 2 sections. You could also maybe say they took the figure number and times it by 2. So that could be another conjecture. Notice each time. Now also, we have to include the little shading. It looks like each time they shaded one little section that was above the halfway point, but over on the left side. So over here's my halfway point, so we could also shade that little section. So a conjecture, you could either have stated like he did. You could say each figure, maybe say increased by 2 sections. That would be a conjecture. Again, you could have stated, like I said, each figure or each circle. You don't have to use figure. So each circle is divided into twice as many regions as the figure number. And these are both conjectures. And again, it's just a sentence that you come up with based on what you're observing in the pattern. And again, this is using inductive reasoning. So another one, it says describe the pattern in the numbers 5.01, 5.03, 5.05, 5.07. It says write the next three numbers in the pattern. So a lot of times when I've got my sequence here and I want to figure out what the pattern is or what's happening, I'll go ahead and write it down. And then again, when you notice that it's increasing and the numbers are getting larger, chances are you're either adding or multiplying. So in this case, I'm going to first try adding, and the way that you could figure out what they're doing is you could take two of the numbers in the pattern and subtract them. So if I subtract 5.03 and 5.01, I could see what happened here is they added 0.02 each time, and that's going to be the same thing each time. So now to get the next three numbers in the pattern, I'm going to take my last number here, 5.07, and I'm going to add 0.02, and my next number in my pattern is going to be 5.09. And then I'll do it again to get the next one. Take the answer I just got, add the 0.02, and then do it one more time because they wanted the next three numbers. So the next three numbers, 5.09, 5.11, and then lastly, 5.13. So your conjecture could have been, we added two 100s or 0.02 each time. So just make a sentence using that number in your sentence. Again, this is using inductive reasoning because you're observing the pattern they gave you to look to see what happened in the past, and then to complete the pattern, you'll repeat that same pattern. So the next one says numbers such as 3, 4, and 5 are called consecutive integers. It wants us to make and test a conjecture about the sum of any three consecutive numbers. So let me go ahead and write down three consecutive integers and let me add them up, get their sum, and see if I start to see a pattern. So let's say I just take the first three. So let's say I take 1 plus 2 plus 3. That gives me a sum of 6. I need to do some more examples so I could start to see a pattern. So let's say I take the ones that they gave me in the problem, 3, 4, 5, add these, I get 12. Still probably don't have enough information. Let me pick some larger consecutive integers to see if that'll help me see a pattern. So let's take 100, 101, and again, they're just numbers in order. And when I add them, I get 303. Anybody seeing a pattern here with the sum? What about if we take a look at this second integer? What are we doing to that second integer to make it become a 6?
It's multiplied by 3 every time the second integer.
Beautiful. So a conjecture you could make is if you take the second number in your consecutive integers, times it by 3, and that'll give you the sum. And it's going to work for any set of 3 consecutive integers Because notice each time, 101 times 3, and it does give me that sum. So my conjecture, based on my observation, using my inductive reasoning, my conjecture, and again, it doesn't have to be worded exactly, something along these lines, I could state that the sum of any 3 consecutive integers is 3 times the second number. You know, another conjecture you could have made is the sums are all multiples of 3. That would be another valid, because again, if you notice, we're timesing it by 3. But again, any kind of sentence that would work for every single sum. And in this case, multiplying that second consecutive integer by a 3 will give you the sum of those 3 consecutive integers. This slide is the definition of a counterexample. So when they're asking you to make a counterexample, what they want you to do is find something that proves the statement false. So it says here, to show that a conjecture is false, provide just one example for which the conjecture is false. When you do that, it's called a counterexample. So an if-then statement is false if you can find one example that can be found for which the hypothesis is true, but the conclusion is false. So that example is called a counterexample. So here's my first conditional example here. It says, if you live in Florida, then you live in Miami. Can someone come up with a counterexample that would prove this statement false? The conclusion, you're living in Florida, the hypothesis, you live in Florida, but you have to live in Miami if you live in Florida. Where else could you live?
Tampa.
Okay, Tampa, Orlando. Any other city in Florida would prove this false. It could be Cooper City. It could be Southwest Ranches. It could be any city in Florida that isn't Miami, and that's your counterexample. And you don't have to give me more than one. All it takes is one to come up when they ask you for a counterexample. There may be more than one, but when it asks for a counterexample, just give one. So the next one, it wants us to find a counterexample. So a student makes the following conjecture about the sum of 2 numbers. Find a counterexample to disprove the student's conjecture. So the student stated that the sum of 2 numbers is always more than the greater number. Now, let me show you an example of this. So let's say I add 1 plus 3 and I get 4. Notice this sum is bigger than both of the numbers. This is something proving it true. I don't want you to prove it true. I want you to come up with 2 numbers that proves that statement false. So what would be 2 numbers that when you add them,
10 and negative 2.
good, okay? 10 plus negative 2 gives you positive 8. This is the sum. It is not more than the bigger number, so this would be a perfect counterexample. All you need to do is come up with one of the numbers being negative, and then that sum will not be greater, okay? You could have also chosen 2 negative numbers, but again, when it asks for a counterexample, just come up with one. So again, we're not trying to prove it true, we're trying to prove it false. Another one would be negative 2 plus negative 3 gives you negative 5. Negative 5 is not greater than negative 2, so this would be another one. But again, when I ask for a counterexample, just give me one. So deductive reasoning uses facts, definitions, properties, and the laws of logic to form a logical argument. So the laws of logic, we're going to learn two of them. So there'll be two laws, and they'll be coming up on the next slides. But deductive reasoning is using things that we know are true, based off of facts. It's not based off when we observe a pattern. So we're following rules here, facts, definitions, properties. So our first law is called the law of detachment. And this law states that if the hypothesis of a true conditional statement is true, then the conclusion is also true. So this symbol right here, P with an arrow, then a Q. Remember, the P is the hypothesis, the Q is the conclusion, and the statement is, if it's Friday, then I eat pizza. So you'll be given a conditional, and then they're going to give you another statement. It may not be in if-then form, and if this is based off of the hypothesis, then you can make the same conclusion. So they are saying, if it's Friday, then I eat pizza. And then someone states, today is Friday. So you can make the conclusion that you will eat pizza today, or I will eat pizza, because it's based off of that true hypothesis. If I stated that today is Thursday, you could not make a conclusion. You might eat pizza, but based off of the conditional, we don't know what happens on Thursday. All right, let's try the next law, called the law of syllogism. And this is used when the conclusion of one of the statements is the hypothesis of the other statement. Now, both of the two original conditionals must be true. So you're going to be given two conditionals. So this is the first one. This is the second one. Now, you don't necessarily have to keep them in the same order that they give them to you, but what you're looking for is a match. You're looking to see that the conclusion of one of the conditionals is exactly the same as the hypothesis of the other. And if it does, these sort of blend together or cancel out, and then your new statement is going to be the original hypothesis with the conclusion of the other conditional. And that would be your new statement. So it blends together. Okay, so here is telling us to use the law of syllogism. Now, on the test and the quiz, I may not tell you which law to use, so you need to understand both. So they're giving me two true conditionals. They want us to write a new conditional statement using the law of syllogism. So remember, what I'm looking for is a match. I'm looking at the conclusion of the first conditional. If it's Friday, then I go to the movies. Notice it's a match with the hypothesis of my second conditional. If I go to the movies, then I eat popcorn. So notice these two blend together, and my new statement is everything that didn't blend together, the overlap. That overlap cancels out. So my new statement is going to be, if it's Friday, then I eat popcorn. So you take what blended together out, and then you write what remained. And that'll be your new statement. Now it wants us to use the law of detachment. So this one, my original conditional is this. If 90 degrees, so if the measure of angle R, that's what this is. If the measure of angle R is greater than 90, but less than 180, then angle R is obtuse. So given that we have an angle in between 90 and 180, then it's an obtuse angle. This is the definition. So the statement they're making, they're telling us that the measure of angle R is 155 degrees. They want to know what conclusion can we make based off of that statement. Well, because angle R being 155 goes into this hypothesis, and it's true, because it is between 90 and 180, the conclusion we can make is this, that R is obtuse. So angle R is obtuse. So if the statement they give you, if it satisfies that hypothesis, then you can make the conclusion that follows the word then. If I would have told you that angle R was 40 degrees, then you couldn't make the conclusion that R was obtuse. So this one, they're giving me two conditionals this time. So my first conditional is right here. So if Janelle gets a job, then she can afford a car. This is my first conditional. My second one, if Janelle can afford a car, then she will drive to school. It wants me to use the law syllogism to see what statement I can make. So again, I'm looking for the overlap. So this conclusion, she can afford a car, is the same as the hypothesis of the second conditional. So that cancels out or blends together. So my new statement is going to be, if Janelle gets a job, then she will drive to school. Let me go ahead and write that as my new statement. If Janelle gets a job, then she will drive to school. Now, on the test and the quiz, I'm not going to necessarily tell you which law of logic. I'm going to ask you to tell me which one was used. So this is what was given, and this is the statement that they're coming up with. And they want us to know or tell them what law was used, syllogism or detachment. So again, this is going to be my first conditional. If you get an A on your math test, then you can go to the movies. The second conditional, if you go to the movies, then you can watch your favorite actor. The statement they came up with was, if you get an A on your math test, then you can watch your favorite actor. Generally, when I see two if-then statements, that's a clue to me that I'm using syllogism. So let's test to see if the conclusion of one is going to cancel with the hypothesis of the other. So here's my conclusion of the first one. It says, then you can go to the movies. And then, again, you don't need to really look at the word then. You're just looking at you can go to the movies. And then notice it's the hypothesis of the second one. So my new statement is, if you get an A on your math test, then you can watch your favorite actor, which is what they came up with. So again, when it blends together or that conclusion and that hypothesis overlap, this is the law of syllogism. All right, state the law. So again, the answer is either going to be law of detachment or law of syllogism. Notice this time I don't have two if-then statements. I've just got one. So this should be a clue that it's probably going to be detachment, but let's check it out. So here is my conditional. If x is greater than 12, then x plus 9 is greater than 20. The statement they're giving us is that the value of x is 14. So I'm going to go over and look at my hypothesis. And if this statement satisfies this inequality, which it does, then I can make the same conclusion that therefore x plus 9 is also greater than 20. And this is the law of detachment. All right, so here all we need to do is decide whether inductive or deductive reasoning is used to reach the conclusion and explain your reasoning. Remember, inductive, we're using an observation or looking for a pattern. Deductive is based on a rule, a fact, a property. So the first one, each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. This is based off an observation or a pattern that you're watching, and every time she kicks that ball, it'll return to the ground. So this would be an example of inductive reasoning because it's based on an observation of a pattern. And then the last one, all reptiles are cold-blooded. Parrots are not cold-blooded. So Sue's pet parrot is not a reptile. And this would be using deductive reasoning because what we're using is a fact that reptiles are cold-blooded animals. So this is based on a fact, and this is why it's deductive.